Hello and welcome to this tutorial. In this tutorial, we're going to answer a 2023 extract question on energetics of chemical reactions. So hydrazine conforms to the following displayed structure, which is this given structure. So in the absence of hydrogen, hydrazine is used as a rocket fuel because it burns easily in oxygen according to the following equation. So that's the equation given. Other than nitrogen and water, which is H2O, what else is produced in this combustion reaction? So the other thing that is produced in a combustion reaction is obviously energy. Explain why hydrazine is considered a clean fuel. So it's a clean fuel because its byproducts they are harmless to the environment. It's environmentally friendly. So it produces that nitrogen. It doesn't pollute the environment. Determine the enthalpy change. Determine the enthalpy change. So how do we determine the enthalpy change of this reaction? So to determine the enthalpy change, obviously we have to know the enthalpy of the reactants plus the enthalpy of the products. So what is the enthalpy of the reactants? The enthalpy of the reactants, when we look at the given reaction, is, so just to elaborate more, when we look at the structure of hydrazine, we have these bonds. We have to understand the bonds involved, and then there is that bond. So provided the equation is balanced, then we can proceed and answer. So here, in terms of bond energies, we have a nitrogen to nitrogen bond, which is giving us a 350. Then we have the nitrogen to hydrogen bond. Remember, these are 4. So it's 4 multiplied by 391. Then oxygen, we have 1, which is 496. So obviously this gives us a 350. The 4 by that gives us I'm trying to use my calculator here. 4 multiplied by 391 gives us a 1564, then 496. So the addition of those, the total comes to a 2410 kilojoules per mole. Okay, then we equally do the same for the products. So I'm putting a positive to indicate that it's an endothermic bond breaking. We are on the bond breaking side. Then we equally do the same for the products. So in terms of the products, there is nitrogen and 2 moles of water. So to elaborate more, for nitrogen we have the triple bond there. Then for water we have 2 of the hydrogen oxygen bond. So in terms of energy, this triple bond is giving us a 944. Then HO bond, remember these are 2, but again we have 2 of those bonds inside, so we can just say 4 multiplied by 460. So 944, that is 9,944 plus a punch on the calculator. This is 460 by 4, giving me a 1840. So when we add this, the total comes to plus, the total comes to 2784, which is a negative because it's an exothermic. Therefore, in terms of the total, let me look for more space. In terms of the total, we do this plus of product. So it's going to be positive 24110 plus negative 2784. Therefore, the total comes to negative 374 kilojoules per mole. So that is the total, which indicates that obviously it's an exothermic reaction because the overall charge is a negative, or sign is a negative. And D requires us to draw fully a well-labeled energy level diagram of hydrazine. So here we'll consider this as energy kJ per mole, then reaction pathway this side, then there are important things that we need to capture in this, such as the enthalpy. So the enthalpy, which is a negative 374. Then we need to capture the activation energy, so that is the activation energy. Then in terms of products, we have nitrogen plus water there. In terms of reactants, we have N2H4 plus O2. Yeah, something like that, but it has to be neat. Then before formation of which is E, before formation of nitrogen and water, they are intermediate products. At a transition point, state whether atoms are bonded or isolated at transition. So at transition, atoms are bonded. It's just that the bonding is partial. The bonding is partial. So they are bonded, but they are in a transition. So the bonding is partial. Okay, see you in the next video.